In February 1944, a German bomber is flying safely over England. The night is calm, almost indifferent. Below, the countryside is erased by blackout regulations. The land reduced to a flat, depthless darkness broken only by a few careless pinpricks of light that will be punished come morning. Above it all, the aircraft moves with quiet confidence, engines droning in a steady, familiar rhythm. There are no fighters in sight. No searchlights glowing upward. No flak bursting in the distance. The sky is empty. The crew relax into that dangerous space between tension and boredom, where survival feels routine. The pilot keeps one hand light on the controls. He has flown this route so many times that the darkness feels mapped, each absence a landmark. He knows where the coast should be without seeing it, knows the turn he will make long before the compass confirms it. The altimeter needle barely trembles. Fuel flow is steady. The engines sound healthy. Everything that can be checked has been checked, and everything checks out. This is not a dangerous moment. This is the kind of moment men survive. Behind him, the navigator traces a finger along a chart illuminated by a dim red lamp, his movements unhurried. The wireless operator listens to static and fragments of German voices, waiting for a warning that never comes. The gunners scan the blackness outside their perspex blisters, eyes aching from the strain of watching for something that has not appeared on any previous flight. Each man performs his role with the quiet efficiency of repetition. This is how normal nights feel near the end of a long war. Mechanical, procedural, almost dull. The aircraft flies straight and level, slicing through frozen air at over 4,000 meters. The channel is somewhere behind them now, an unseen boundary already crossed. There is no reason to climb, no reason to descend, no reason to change course. The bomber is not being hunted. It is not even being noticed. 30 seconds later, it no longer exists. There is no flash that the crew understands as an attack. No visible explosion ahead. No impact felt in time to react. The starboard wing does not fail gradually or catastrophically in the way training manuals describe. It simply comes apart. Metal tears free in overlapping screams. Rivets shear in unison. Aluminum skin peels back as if unfastened by an invisible hand. The aircraft shudders once, violently, as though surprised by its own disintegration. The controls go slack. Lift vanishes. The bomber rolls, then drops into a spiraling descent, the night sky spinning where the horizon should be. Inside the cockpit, voices rise. Not orders, not procedures, but questions shouted into a void that does not answer. What was that? Did we hit something? Where did it come from? The gunners see nothing. The navigator sees nothing. The pilot has no time to try anything. The aircraft is no longer an aircraft. It is debris falling faster than human thought. When it hits the ground, it does so across 3 fields, scattering pieces of itself into hedgerows and frozen soil. There is no fireball to announce the end, no dramatic column of flame visible for miles. Just wreckage settling into the countryside, steaming quietly in the cold. At first light, men arrive on bicycles and lorries, boots sinking into mud as they move among the remains. They expect bullet holes. They expect shrapnel scars. They expect signs of a fight. They find none. The fuselage is torn open, but not punctured. The engines are damaged, but not shot through. There is no pattern that makes sense, no familiar story written in metal. Only the unmistakable fact that something broke the aircraft apart while it was still whole and flying normally. The paperwork is brief. Enemy bomber destroyed. Cause unknown. There is no space on the form for confusion. That night will not be remembered by the men who died in the air, nor by the ones who quietly collected the pieces at dawn. But it will mark a moment when certainty slipped out of the war without announcing itself, when routine stopped offering protection. Somewhere in the darkness, something had reached up and touched an aircraft that did not know it was being watched, and the sky had proved far more dangerous than it looked. The men who examine the wreckage know what they are looking for. They have done this before. Bullets leave clean, circular holes. Cannon shells tear metal in a way that tells a clear story. Shrapnel embeds itself, leaving signatures that can be traced back to a weapon, a caliber, a direction. This wreckage tells none of those stories. The fuselage is ripped open as if stressed beyond its limits, not pierced. Control cables are snapped, not severed. The wing root has failed catastrophically, but without scorch marks, without impact scars, without anything that suggests an enemy ever laid eyes on the aircraft. It looks less like a victim of combat and more like a machine that simply decided to stop being whole. They walk the field slowly, measuring distances between fragments, trying to reconstruct a sequence that refuses to assemble. 3 fields. Too wide a scatter for a low-altitude hit. Too violent for gradual fatigue. The bomber did not limp. It did not descend under control. Came apart all at once, high in the air at speed. One of the investigators crouches beside a twisted section of wing spar and runs a gloved hand along torn aluminum. He shakes his head. This kind of failure should require immense force, delivered suddenly and precisely. Yet there is nothing here to explain where that force came from. The report that follows is thin. There is no room in wartime paperwork for unanswered questions. Enemy aircraft destroyed. Probable cause, unknown. The file is closed and stacked with dozens of others that read almost the same. Crews are dying without encounters. The sky is killing them, but it is doing so without leaving fingerprints. While investigators puzzle over broken metal in English fields, Britain is fighting a different kind of losing battle. Night after night, bombers cross the coast, slipping through defenses that look formidable on maps and in briefings. Searchlights rake the clouds, but clouds can be chosen, and darkness can be used. Heavy anti-aircraft guns fire until their barrels glow, filling the air with black bursts that look impressive from the ground and mean almost nothing at altitude. The shells explode where the bombers were seconds ago, not where they are now. Mathematics is cruel. A bomber at 4,000 meters, moving at hundreds of kilometers per hour, is never where you think it will be by the time a shell arrives. Crews work mechanical predictors with practiced hands, feeding in speed, altitude, wind, course, trusting gears and cams to guess the future. Sometimes they guess close. Rarely they guess right. Most of the time, they fill the sky with noise and hope. Night fighters wait for radar contacts that flicker and fade. Even when radar works, it only brings them near. A pilot still has to see the enemy to kill it, and seeing anything on a moonless night over clouds is a privilege, not a guarantee. By 1944, everyone involved knows the truth, even if no one says it out loud. Britain is expending enormous effort for minimal return. Tens of thousands of shells, thousands of sorties, countless hours of vigilance, and the bombers keep coming. Pressure builds quietly, not panic, something colder. A recognition that bravery and experience are no longer enough, that the system itself is failing. The defenses are working exactly as designed, and that design is no longer sufficient. The night sky has become a problem that cannot be solved by more of the same. Somewhere between the broken aircraft in the fields and the empty skies, the guns keep missing. An uncomfortable question hangs unspoken. If nothing visible is stopping the bombers, what happens when something invisible finally does? The guns did not fail because the men behind them lacked skill. By 1944, British anti-aircraft crews had become specialists in a craft no one had wanted to master. They knew their weapons by weight and vibration, by the way metal rang when stressed, by the smell of burnt propellant that clung to uniforms long after dawn. Many of them had been firing night after night since the Blitz, learning through repetition what no manual could fully teach. They could work in darkness, in rain, in freezing wind, hands numb, ears ringing, eyes burning from hours of scanning a sky that rarely rewarded attention. They did everything right, and still the bombers passed through. The failure was not human. It was mathematical. A shell left the barrel at tremendous speed, but speed was not enough. It had to climb thousands of meters through air that resisted it, slowing it, bending its path. Took seconds to reach altitude. In those seconds, a bomber traveling hundreds of kilometers an hour had already moved far beyond the point the shell was meant to reach. The shell burst where the aircraft had been, not where it was. Every calculation was an attempt to predict the future, and the future stubbornly refused to be precise. Mechanical predictors clicked and whirred beside the guns, fed with data, speed, height, bearing, wind. The machines did their best, translating human observation into angles and timings, but even their best output was still an approximation. A gust of wind, a slight course correction by the pilot, a misjudged altitude, any one of these was enough to turn a near miss into nothing at all. The margin for success was brutally narrow. To score a kill, everything had to go right at once. For the bomber, only one thing had to go wrong. Crews understood this instinctively. They watched shells bloom into black clouds far from their targets, watched bombers slip between bursts with infuriating ease. They knew when a barrage looked impressive but meant nothing. Yet they kept firing. Orders were orders, and presence itself had value. A sky full of explosions might not kill, but it could frighten, disrupt, force altitude changes. It was better than nothing. Still, the numbers told a story no one liked to repeat aloud. Thousands of shells for a single aircraft. Entire nights of effort for negligible effect. There was no bitterness in this realization, only a slow, grinding pressure. Britain could not afford to lose the night sky, not with invasion looming and industry stretched thin. The defenses were working as designed, and that design was no longer sufficient. More guns would not change the equation. Better training would not compress time. Bravery could not overcome physics. Somewhere within the system, a quiet acceptance spread. If the math could not be beaten, then the math itself would have to be rewritten. That acceptance did not take the form of a dramatic declaration. It surfaced instead as questions, tentative at first, then increasingly bold. Engineers, physicists, and radio specialists, many of them veterans of earlier breakthroughs, stared at the same tables of figures and saw not failure, but constraint. If predicting where an aircraft would be was the problem, then prediction was the wrong approach. The shell was blind and obedient, exploding when told, whether or not anything was there. What if blindness was the flaw? The idea that followed felt dangerous, not in the sense of physical risk, but in implication. Weapons had always been extensions of human will. They acted when commanded, struck where aimed, detonated when told. To imagine a shell that chose its own moment was to blur a boundary that had held since the first cannon was fired. It suggested a machine making a decision, however simple, without a human hand on the trigger at the final instant. What if, instead of exploding on a timer or on impact, the shell waited? What if it listened? What if it sensed when it was close enough, not when it was scheduled? The question was radical precisely because it was logical. If a shell could detect the presence of an aircraft directly, then time ceased to matter. Distance became the trigger. The shell would no longer need to guess where the bomber might be. It would react to where it actually was. The burden of prediction shifted from the gun crew to the projectile itself. In that shift lay the promise of something entirely new. Not everyone was comfortable with the idea. It felt unorthodox, almost improper. Allowing a shell to decide when to explode sounded like science fiction, or worse, like surrendering control. Yet the alternative was clear and unappealing. Continue firing tens of thousands of rounds into the night and hope probability eventually favored you. The war did not have the luxury of hope. The early conversations were cautious. No one spoke of intelligent weapons or autonomous systems. The language was technical, restrained. Detection, proximity, triggering mechanisms. But beneath the terminology lay a profound change in thinking. The shell would no longer be a passive object hurled skyward. It would become an active participant, a brief but decisive sensor, alive to its surroundings for a few critical seconds. For those who grasped the implications, the unease came hand in hand with excitement. If this could be made to work, if electronics could be hardened enough, miniaturized enough, reliable enough, then the entire logic of air defense would shift. The sky would no longer be a vast space where defenders guessed and attackers slipped through gaps. It would become a volume filled with invisible thresholds, lethal not because they were seen, but because they were felt. The idea crept forward quietly, sheltered by secrecy and necessity. It did not yet have a name that captured its significance. It was just a concept, an answer to a question that had not been asked out loud for long. But it carried with it the unmistakable weight of inevitability. Once someone had imagined a shell that waited until it was close enough, there was no going back to shells that exploded blindly. For the gun crews still standing watch in the cold, none of this was visible. They continued to fire, continued to trust procedures that no longer worked as promised. But somewhere beyond their sight, the war was beginning to tilt. Not through louder explosions or faster aircraft, but through a subtle transfer of judgment from human hands to a device small enough to fit in the nose of a shell. It was not yet deployed. It had not yet proven itself. But the moment the question was asked, what if the shell decided when to explode? The old balance was already breaking. The night sky did not know it yet, but it was about to become a place where routine offered no safety, where invisibility cut both ways, and where the future arrived not with spectacle, but with terrifying precision. The shell left the gun barrel at a speed that should have annihilated everything inside it. The moment of firing was violent beyond intuition, an instant where metal went from stillness to supersonic motion under forces exceeding 20,000 times gravity. Anything fragile should have ceased to exist in that fraction of a second. Glass should have shattered. Filaments should have snapped. Circuits should have collapsed into useless debris. For decades, that reality had defined what could and could not be placed inside a projectile. Electronics belonged in laboratories and aircraft, not inside shells hurled into the sky like blunt instruments. And yet this shell survived. Inside its nose, sealed behind hardened metal, was something no artillery round had ever carried before. A functioning electronic system. Not passive, not inert. Alive in the briefest, most literal sense of the word. The instant the shell cleared the muzzle and stabilized in flight, the system woke up. Power flowed. A signal began to transmit outward into the dark. It was not powerful. It did not need to be. It whispered into the night at a frequency chosen with care, a balance between range and reliability. The signal spread outward in all directions, invisible and indifferent, passing through cold air and clouds alike. For most of the shell's short life, nothing answered back. The signal simply radiated into emptiness as the projectile climbed, arcing toward a point no one could predict with certainty. Then, somewhere ahead, something metallic moved through that invisible field. When the radio waves struck the aircraft's skin, they did not vanish. They returned, distorted, shifted, altered by motion. The change was subtle, but it was unmistakable. The frequency slid ever so slightly, transformed by the relative speed between shell and target. This was not guesswork. It was physics, immutable and precise. The faster the closing distance, the stronger the shift. The nearer the aircraft, the clearer the signal became. Inside the shell, tiny vacuum tubes, reinforced, thickened, designed to flex rather than shatter, did their work. They amplified the returning echo, compared it to the outgoing signal, and measured the difference. Capacitors charged. Thresholds were crossed. The system did not know what it was sensing in any human sense, but it knew one thing with absolute certainty. Something large and metallic was now close enough to matter. The decision took less time than a blink. When the conditions were met, when distance collapsed into lethality, the circuit closed. A detonator fired. High explosive became a storm of fragments expanding faster than sound. From the outside, it looked like any other flak burst. From the inside, it was something entirely new. The shell had not exploded because time ran out or because it struck something solid. It exploded because it chose the moment when distance became fatal. In that instant, prediction vanished from the equation. The future was no longer guessed. It was measured. The engineering that made this possible bordered on the improbable. Every component had to survive not only the firing shock, but freezing temperatures, vibration, turbulence, and the sheer chaos of ballistic flight. Batteries had to deliver power reliably despite forces that would crush ordinary cells. Tubes had to glow and function while being hurled through the air at hundreds of meters per second. Connections had to remain intact when any weakness meant total failure. There was no redundancy, no second chance. Each shell either worked perfectly or did nothing at all. Thousands were tested. Many were destroyed in the process. Engineers learned what broke, then redesigned until it didn't. Filaments were thickened, glass envelopes reinforced, internal supports reshaped to absorb shock rather than resist it. What emerged was not elegant in appearance, but it was ruthless in function. A device stripped of everything unnecessary, built solely to survive long enough to make one decision. For months, this theory remained married to testing. Proof without consequence. Then came the night it was finally unleashed. The gunners did not know what they were firing. They knew only that new fuses had arrived, sealed and unexplained, accompanied by orders that emphasized procedure but offered no detail. Veteran crews handled the shells as they always had, loading them into breeches, checking elevations, trusting the familiar rituals that governed their nights. The guns traversed. The predictors clicked. The radar plots stabilized. Everything looked the same as it had 100 times before. When the order to fire came, it sounded no different. The first shells climbed into the darkness, their ascent marked only by the dull thump of guns and the distant hiss of passage. Observers waited for the usual pattern. Bursts scattered ahead of the targets, black clouds blooming harmlessly in empty air. That was what experience promised. Instead, something else happened. A shell detonated beside an aircraft. Not ahead of it. Not behind it. Beside it. The explosion was close enough to matter. The bomber jolted visibly, its formation breaking as crews reacted too late to something they could not see. Another shell burst near another aircraft. Then another. Not random. Not clustered where the predictors said the bombers would be, but where they actually were. Observers blinked, then leaned forward, trying to reconcile what they were seeing with everything they knew about flak. Bombers began to stagger. One rolled away trailing smoke. Another lost altitude abruptly, its engines coughing. A third simply vanished from the formation, replaced by a falling smear of flame. The sky, which had resisted for years, suddenly seemed to cooperate. On the ground, gunners exchanged looks they did not voice. They kept firing because that was what they were trained to do, but something fundamental had shifted. The explosions were no longer decorative. They were surgical. Each burst felt purposeful, as if the sky itself had learned where to strike. For the men in the aircraft, the experience was something else entirely. There was no warning, no pattern to evade, no visible curtain of flak to weave through. Explosions appeared where safety should have been, at moments that defied instinct. Pilots pulled into turns only to have shells burst alongside them anyway. Navigators watched instruments and trusted routes that suddenly offered no protection. Gunners fired into darkness at enemies they could not see and could not approach. Panic crept in, not as terror, but as disbelief. This was not how anti-aircraft fire behaved. This was not something training prepared them for. The sky had become hostile in a new way, quietly, intelligently, without spectacle. It did not announce danger. It simply delivered it. By the end of the night, wreckage lay in places where it had not before. The aircraft failed to return. Those that did carried scars too precise to ignore. Dozens of small holes clustered where no shell should have burst. Reports were written with careful language, describing unusual accuracy, improbable proximity, inexplicable timing. No one used the word impossible, but everyone felt it. On the ground, the effect was almost as profound. For the first time in years, the guns felt vindicated. Not triumphant, just justified. The endless nights of firing into nothing had been a prelude, not a failure. The system had not been broken. It had been incomplete. Now suddenly it worked. No speeches marked the change. No announcements were made. The weapon remained unnamed, its existence buried under classification and routine. But the results spoke for it. Bombers turned away earlier.
Formation loosened.
Routes changed. The night sky, once a corridor of relative safety, became unpredictable and lethal. What had changed was not the volume of fire or bravery of crews. It was the nature of the interaction itself. For the first time, the shell was not a message sent blindly into the future. It was a question asked of the present, and answered instantly. The future had arrived not with fanfare, but with quiet precision, wrapped in steel and electronics, surviving forces that should have destroyed it, listening in the dark, and waiting patiently for the exact moment when distance collapsed into destruction. The first hints that something was wrong emerged not as panic, but as unease. Luftwaffe crews returning from night sorties over southern England began to write reports that felt oddly restrained, as if the writers themselves did not fully trust what they had experienced. The language was careful, technical, stripped of emotion. Flak effectiveness appears increased. Bursts observed at unusually close range. Aircraft sustained damage without direct hits observed. At first, these accounts were treated as statistical noise. War had a way of sharpening memory around fear, and anti-aircraft fire had always been unpleasant. But as the nights passed, the reports multiplied, and their similarities became impossible to ignore. What disturbed crews was not simply that flak was more accurate. It was that it behaved differently. Pilots described explosions that seemed to occur alongside the aircraft during turns, not where logic said they should. A bomber would alter course, trusting that the familiar delay between maneuver and shell burst would create space, only to feel the airframe shudder as an explosion blossomed unervingly close. Navigators noted bursts that coincided with altitude changes, arriving just as a climb or descent was completed, as if the shell had waited for the maneuver to finish. This was not how flak worked. It was not how it was supposed to work. For years, survival at night had depended on pattern recognition. You watched the bursts, judged their timing, adjusted speed and heading accordingly. You learned the rhythms of ground fire, learned when it was dangerous and when it was merely noisy. Now there were no rhythms to read. The sky no longer telegraphed danger. Explosions arrived without warning, without visible buildup, without the reassuring sense that experience still mattered. Against fighters, you could maneuver. Against traditional flak, you could adapt. Against this, there was nothing to adapt to. Fear crept in quietly, disguised as confusion. Crews began to second-guess instincts that had kept them alive for years. Some flew straighter, avoiding aggressive maneuvers not because it was safer, but because movement no longer seemed to help. Others altered altitude constantly, searching for a band of air where the danger might lessen. None of it worked reliably. Losses accumulated not in dramatic spikes, but steadily, insidiously. The aircraft failed to return. Survivors landed with damage too precise to dismiss, clusters of small holes, control surfaces shredded by fragments from explosions that no one had seen coming. Speculation filled the vacuum left by understanding. Rumors circulated between crews in low voices. Some believed the British had developed remotely controlled shells, guided after firing by operators watching radar screens. Others suggested acoustic devices triggered by engine noise, or optical systems reacting to moonlight reflecting off wings. The theories grew more elaborate as certainty collapsed. Anything was preferable to the idea that the shells themselves were making decisions, because that idea implied a loss of agency that was deeply unsettling. It suggested that skill, judgment, and experience had all been quietly downgraded. By the time senior commanders accepted that something fundamental had changed, the psychological damage was already done. Night operations over southern England began to feel less like calculated risk and more like exposure. Crews still flew, orders still came, but confidence eroded. The night sky, once navigable through discipline and familiarity, had become opaque and hostile. When pilots no longer believe their actions meaningfully influence survival, defeat becomes a matter of time. The bomber that disintegrated over the Sussex countryside had not died by chance. It had died because the war crossed a threshold that night, one that would never be uncrossed. A boundary separating human reaction from machine judgment was breached quietly, without ceremony, and the consequences rippled outward long after the wreckage cooled in the fields below. What destroyed that aircraft was not merely an explosion, but a principle made real. The idea that sensing could replace seeing, that proximity could replace prediction, that a machine, trusted for a fraction of a second, could make a decision more precise than any human calculation under fire. Once that idea proved itself, it became irreversible. It did not matter that the device was small, crude by later standards, hidden behind secrecy and paperwork. It worked, and that was enough. In the years that followed, the concept would spread and evolve. Proximity fuses would become standard. Radar would shrink. Missiles would inherit the same logic, then computers, then systems far removed from artillery and bombers. But the essence would remain unchanged. Measure the present. Act instantly. Remove the delay where humans once stood. The men who found the wreckage near Lewis never saw that future. To them, it was just another broken aircraft. Another unexplained loss in a long and exhausting war. The forms were filled out. The site was cleared. Life moved on. Yet in hindsight, that night stands as a quiet turning point. A moment when warfare stepped decisively into an era of invisible architectures and autonomous response. The bomber never saw the enemy because the enemy was no longer something you could see. It was radio waves moving faster than sound, electronics surviving impossible forces, and a decision made in 1/3000th of a second. The future arrived early, without warning, and once it arrived, the night sky over England was never the same again.